Hello everyone and welcome back to a video lecture series on computer architecture. My name is Dr. Prashant Bachanna. In this video lecture, I am going to discuss about the register transfer operations and bus and memory transfers. So in the previous lectures, we have seen like the register transfer language. At least in the register transfer language, there will be a transfer of information between the registers. So here we'll see some different types of register transfer operations and how the data is transferred between the bus and memory. So we'll see the register transfer operation. So basically it is divided into three types. The general types are this one. So in the register transfer operation, the operation performed on the data stored in the registers are referred as register transfer operations. So whenever CPU executes, CPU or the processor executes any operations, so those operations will be executed with the help of the registers. So there will be different types of registers like R1, R2, like we have seen in the previous videos. Two types of registers are there. The first one is general purpose registers, and the second one are special purpose registers. So in the register transfer language, that is in the register transfer operations, what will happen is that the data stored on the registers, let us say there are two registers R1 and R2. So the data stored on the operation performed on the data stored in the registers are called as the operations of this. So with the help of these different types of registers available, so we will do the operations. With such operations, we call it as the register transfer operations. So in this we will see one by one what are the different types of operations are used. So the first type is a simple transfer. So in the simple transfer, what will happen? So we have taken an example here. We'll take one example. So the example is the content of R1 arrow towards this left side R2. So this is an example for the simple transfer. In this, what will happen after executing this operation? The content of the register R1 is moved to the R2. So the content of R1 is copied into the R2 and the content will be stored in this R2. So this is an unconditional type of operation. So that is the first type of register transfer operations, is that they will be performing the different operations on the data stored in the register. So the first one is called simple transfer. If you want to transfer it, so we will use this symbol to transfer. So this symbol is used for transferring the data from R1 to R2. Then the next type of, so in the first example is a simple transfer. In the second example, we'll transfer the content with the help of some conditions. So it is called as conditional transfer. So in the conditional transfer, the content of the register R1 is moved to the R2 when P equal to 1. So if we write, so the instruction is P colon R2. So the difference between the previous and this one is this. In this, we are mentioning some condition, that is the control function is used when P equal to 1. When P equal to 1, the content of the register R1 is moved to R2. So the content of the register may be 8 bit. That is, here N is the number of bits here. So the size of the registers here R1 and R2 may be like 8 bit or 16 bits depending on the processor. The third type of operation is the simultaneous operation. So as the name itself, it is indication if we have two or more operations to occur at the same time, then we use these simultaneous transfer operations. In this, we can simultaneously transfer the content of the register R1 to R2 and vice versa, that is from R2 to R1. So here also we will be writing that equation with this. So I will be writing P R2 R1. So this will move the content of R1 to R2. Then here we use a colon. So to perform this operation, we use this symbol, comma R2. So what this will do? So when P equal to 1, the content of R1 is moved to R2, and at the same time the content of R2 is moved to the R1. So such kind of operation is called as a simultaneous operations, wherein we can simultaneously transfer the content of one register to the another register at the same time, and all these things will be performed with the help of the clock here, because at the same time we cannot do so with the help of the clock when at particular time for the first instant the content of R1 is moved to R2, and in the next clock cycle, in the next time, the content of R2 is moved to the R1 with the help of the clock. So with the help of the clock, the simultaneous operation is being performed. So these are the three types of the operations performed. Next, we will see the memory transfer. So memory transfer is one among the very important function in the computer architecture. That is, in the memory transfer, as the name itself it is indicating, a memory word will be symbolized with the letter 1. So it is symbolized with the letter M, and the particular memory word among the many available is selected by the memory address during the transfer. So whenever memory transfer is happening, so N among the available memory locations from M is one of the memory will be selected among the N number of memory locations available in the main memory. So this will be done by enclosing the address in the square brackets following the letter M. So whenever we are doing any operations on the memory, so we'll be writing M, capital M, then we'll be writing in the square brackets. In that, let us say if I write M square bracket AR, so that is the content of the address register. That is, the address register is stored in some memory locations, in some memory location in the main memory. Let us say the same example, consider the memory unit that receives the address from a register. It is called as the address register. So if you want to transfer the content of AR into the memory, what we'll do is that the data are transferred to the another register. It is called as data register, which is symbolized by DR. Okay, so we can write like this: M AR or M data register. Then the next operation is a read operation. So if you want to read anything from the memory, so that operation is performed here, that is in the memory transfer. So basically there will be two types of operations in the computer, that is read and write operation. So the read operation, as the name itself is indicating, it will perform only the read operation. So only we can read the content of the data present in the memory. So the transfer of information from the memory word to the outside environment is called as a read operation. So how it is represented? So the read operation is symbolically represented as M here. Capital M represents the memory address. That is the total memory. In that, like memory means it will be like this. So it will have thousands of locations. So in some memory location, let us say like 001. So here this AR is present. So when we do a read operation, what will happen, that the transfer of information from the memory to the data register will happen. That we have to remember a very important this thing. So during the read operation, the content of the that is the transfer of information from memory word to the data register is moved, or it is to the outside environment. So this causes the transfer of information from the memory word M selected by the address in the DR. So when we do the read operation, when the read operation is done, so the content from the AR is moved to the data register. So similarly, we can go for the write operation, transfer the content of the data register to the memory from the M selected address. So these are the operations. Yeah, so this is the write operation here. So in the write operation, it will be exactly operation. So if you want to store some information, so the write operation in the sense, so these are the our main memory. So in the write operation, we'll be storing some sort of information or data into the memory. So here, how we will be writing the write operation, that is the transfer of new information to be stored in the memory. So how it is, like if you write R1 and this MAR. So what this instruction will do is, this causes a transfer of information from R1 into the memory word selected by the addresses in the address register. So here AR stands for, it's a register, 16-bit register, which is called as address register, which holds the address. address of the memory location. So once we discuss all these operations, next topic is our bus transfer. So the bus in the computer architecture, a bus is used to connect two or more number of components, or to connect the n number of registers present here. So is a path. Bus is basically a path or group of the wires over which the information is being transferred, and from any of several sources to any of the several destinations. So with the help of the bus, what we can do, we can send the information from one place, that is source, to the destinations, from one source to the n number of destinations at the same time. So for that purpose, we use the bus. So one way to construct a common bus is by using the multiplexer. So we can use multiplexers for building the buses here, because what is multiplexer? Multiplexer will have n number of inputs and single output. So the multiplexer selects the source register whose binary information is then placed on this. So with the help of, we can do it. So example of this one is, let us say there are 4 registers are there. You can use do with this. So the register A is selected when it is 00, then 01. Register B is selected, then 10, then for 11. So this is for like 0, 1, 2, 3. So this is with the help of the multiplexer, that is like 4:1 mux. So we can develop this bus here. So wherein the content of the data can be accessed and can be sent from source to the destination with the help of the buses. So this is an example of the 4x1 multiplexer. So here the same the 4 registers are there here: register A, register B, register C, register 3, and we are used 4:1 mux. So what is the function of the 4:1 mux? So 4:1 mux is a mux in which we have 4 inputs and one output here. So the register A is connected, and that is 0, 1, 2, 3. The 0, 1, 2, 3 in the sense it is 0, 0. This is 0, 1. This is 1, 0. This is 1, 1. So each time one of the input will be selected. So like this, we have the 4 registers are connected to the 4:1 multiplexers. Here 2 select lines are there. So these select lines will work like this: 0, 0, 0, 1, 1, 0, 1, 1. So for these inputs, the select lines, so the first time the select line will be 0, 0. Okay, the register A will be selected. Then for 0, 1, register B will be selected. For 1, 0, for 1, 0, for 0, 0, register A will be selected. For 0, 1, register B will be selected. 1, 0, 1, 1. So like this, we use this bus transfer here. So these are like 4 line a common bus here we can use. So each time here, with the help of, there are 4 registers are there, the transfer is done with the help of 4:2. Each time one of the register will be selected. So this is the construction of the working of the bus transfer. Yeah, the same thing, whatever I have this thing. So the 4 registers are selected. So when it is 0, 0, register A is selected, when 0, 1, register B is selected, C and D. So the same thing, the bus transfer can be implemented with the help of a decoder, that is 2:4 decoder. Here also we have taken 4 registers, that is R0, R1, R2, R3, and these are the bus lines here. So all these 4 registers are connected to 2:4 decoder. So in the 2:4 decoder, so the 4 R0 registers are connected here, and these are the select lines here. So what select lines will do? 0, 0, 0, 1, 1, 0, 1, 1. For 0, 1, 2, 3 inputs, the buses will be selected. So then we are talking about the buses here. So here one of the important bus, this one is a tri-state buffer here. That is, it is also called as tri-state buffer or 3-state buffer. So a bus can be implemented with the help of a 3-state buffer instead of using multiple. So in the previous slide we have seen that the bus is being implemented with the help of a multiplexer. So we can implement the bus with the help of tri-state buffer also. So as the name itself, it is indicating, so this is a symbol of a 3-state buffer. So it is a digital circuit that executes 3 states. So as the name itself, it is indicating 3-state buffer or tri-state buffer means, so it will have 3 states. So what are these states? Two states are like here normal, that is 0 and 1, and the third state is called as the high impedance states. So for output for y equal to a, that is if c equal to 1, it will be in the high impedance state. So the output y will be equal to a if C equal to 1 and if C equal to 0, that is the third stage is the high impedance state. So the high impedance state behaves like an open circuit. That means the output is open here. So there will be three states here. The one state is 0, another state is 1, and the third state is the high impedance state in which the circuit is open. So this is the diagram which shows the diagram of the three-state buffer. As you can see here, the two select lines are there, and output like 0, 1, 2, 3 here, and they are connected to three buffers here. So A0, B0, C0. So these 0, 1, 2, 3. 0 is connected to this buffer. Then 1 is connected to the B0, 2 is connected to C0, then 3 is connected to D0. So all these bits are shorted and they are being given 1. So to construct a common bus for 4 registers, so we can use like this. If you want 8 bit of registers, we can similarly use these buffers. So in this slide, we have seen instead of using the multiplexers for constructing the buses, we can use the tri-state buffers for building the buses here. Like this for like 4 bit or 8 bit. So then we'll discuss about the memory transfers here. Like already we have seen the memory, two types of memory operations, that is read and write here. So the transfer of information from memory to the word. So here just like we'll summarize it in the read operation, the content of the memory like in particularly will be read, and the content from AR will be moved to the data register. So whereas in case of the write operation, the content from any register will be moved to the AR, which is stored in some memory locations in the which is stored in some particular location in the main memory. So this is the summary of the operations here. So if you write A as like B arrow mark towards A left side, it is called as the transfer. So this symbol is used for transfer of data from one register to the A. So when you write this information will be done. Then we use this symbol, that is AR, that is into the DR, that is AD is here address register and the data register. Then we can write like R1 arrow mark towards A bus also. Then you can write this one. Then AR is some of the terms you have seen. AR stands for address register. DR stands for data register. Then M stands for the memory, and R stands for specific location in the memory. So whenever we write here, then DR is for data register. So here basically in the this module we have to remember the CPU executes all the operations with the help of some registers here. So what are those registers? Address register, which is represented by AR. So in this, address will be present. In the data register, data will be present. Okay, in the instruction register, instruction is present. Then there will be a program counter. Program counter holds the address of the next instruction to be executed, and whenever it is done, each time the program counter is incremented by 1. So these are some of the general abbreviations you have to remember. So that's all in the today's presentation. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.